Today, we're diving deep into one of the most famous, most chilling sounds ever to come out of the abyss. It's a mysterious, incredibly powerful noise known simply as the bloop. For years, it baffled scientists and had people whispering about a giant monster lurking in the deep. So, what really made that sound? Let's get into it.
All right, picture this. It's the summer of 1997. Researchers at NOAA, that's the National Oceanic and Atmospheric Administration, are listening in on the deep ocean with this amazing network of underwater microphones. And then, out of nowhere, they pick up a sound from a desolate corner of the South Pacific that is just unlike anything they had ever heard before.
And when I say this sound was powerful, I mean it was immensely powerful. Get this, it was picked up by hydrophones, underwater mics, that were more than 5,000 kilometers apart. To put that in perspective, that's like something making a noise in Los Angeles and it being heard clearly all the way over in Hawaii. The energy that takes is just staggering.
So just how loud are we talking about? Well, the first thing scientists did was compare it to the loudest animal we know of on the entire planet, the blue whale. But the bloop wasn't just a little louder, it was significantly louder, which immediately ruled out any known creature.
But here's the twist, the thing that made this a true mystery. Despite its raw power, the sound's unique acoustic fingerprint, it looked alive. It had this frequency shift that was eerily similar to an animal call. And that one observation, that little detail, kicked off more than a decade of wild speculation. So, naturally, the first big theory was also the most exciting one. Could this be the voice of some colossal, undiscovered creature? I mean, an organic-sounding call louder than a blue whale. It had to come from something truly gigantic, right?
But you know, when you start to look a little closer at the evidence, that whole story begins to fall apart. A blue whale's song is tonal. It has these clear, structured frequencies and harmonics. It's musical. The bloop, on the other hand, was what scientists called broadband. It was just a chaotic, messy rumble, more like deep-sea thunder than a voice.
And here's the real nail in the coffin, the sheer biological impossibility of it all. When researchers actually did the math, they figured out that for a creature to make a sound that loud, it would need to be many, many times larger than a blue whale. We're talking over 100,000 tons. An animal that big just couldn't survive. It's simply not possible.
Of course, pop culture absolutely fanned the flames on this one. As it turns out, the sound came from a point on the map that was surprisingly close to Arle, the mythical sunken city from H.P. Lovecraft's stories, where the monster Cthulhu is supposedly sleeping. I mean, you can't make this stuff up. The internet obviously had a field day with that.
And his whole thing reveals something fascinating about how we perceive sound. The only reason we even call it the bloop is because the recording that was released to the public was sped up 16 times its normal speed. At its real speed, it wasn't a quick little bloop at all. It was a long, slow, grinding rumble that lasted for over a minute.
Okay, so if it wasn't a monster, then what in the world was it? Well, to get to that answer, we first have to talk about the incredible technology that let us hear this thing in the first place.
Believe it or not, the ears we use to listen to the deep ocean were actually Cold War military tech. The SOFAR hydrophone network was a top-secret system the U.S. Navy built to track Soviet submarines. After the Soviet Union fell in '91, this amazing infrastructure was handed over to scientists, and it opened up a whole new world of ocean research.
But for that network to work across such huge distances, the sound needed a path. And the answer is something called the SOFAR channel. You can think of it as a natural sound highway deep in the ocean. The conditions there are just right to trap low-frequency sound waves and let them travel for thousands of kilometers with barely any loss of energy.
So with the monster theory pretty much debunked, and with a better understanding of the tech, the investigation took a really critical turn, away from biology and towards that massive frozen continent at the very bottom of the world, Antarctica.
The huge breakthrough came between 2005 and 2010. A team led by a NOAA seismologist named Robert Diazak put a new set of hydrophones way closer to Antarctica. And what did they hear? They heard bloops. Not just one, but tens of thousands of them every single year, all with that same exact acoustic signature as the one from 1997.
It turns out there's a name for these events: cryoseisms, or, put more simply, icequakes. These aren't your typical earthquakes caused by tectonic plates. No, these are tremors generated by the colossal forces of massive icebergs and glaciers cracking and breaking apart. The bloop wasn't a roar. It was the sound of a continent of ice shattering.
So how does ice make so much noise? Well, there are a few main ways. The most dramatic is called calving. That's when a piece of a glacier the size of a city just snaps off and crashes into the ocean. But you also get these huge sounds from giant icebergs grinding against each other, or the bottom of an iceberg literally gouging out the seafloor.
And the final, definitive proof, the real aha moment, came when scientists were monitoring the death of one specific iceberg called A53A. As it disintegrated, they recorded its icequakes, and when they compared the spectrogram of those sounds to the original 1997 Bloop, it was a near-perfect match. That was the acoustic smoking gun.
And so, 15 years after it was first heard, the mystery was officially solved. In 2012, NOAA made the announcement, the Bloop was not a monster. It was the sound of ice. The case was finally closed. But in a lot of ways, the real story was just beginning.
Because, you see, solving the mystery of the Bloop ended up revealing something far bigger, and frankly, far more terrifying. It turned this weird, spooky sound from a fun curiosity into a critical data point about the health of our planet. The lead researcher Robert Ziak said it best. He called these sounds a siren call. They are an audible, measurable signal of the accelerating rate at which our polar ice caps are fracturing and melting. We weren't hearing a monster. We were hearing the sound of our planet changing. Fast.
And the cause for all this noise is crystal clear from the data. The Antarctic Peninsula, where a lot of these icequakes come from, is one of the fastest warming places on Earth. More heat means more fractures, more calving, and a much, much louder ocean.
And this isn't just some harmless background noise. This rising chorus of icequakes is basically a new kind of acoustic pollution, and it's happening in the exact same low-frequency band that baleen whales, like blue whales, use to talk to each other across vast distances. This noise is literally drowning them out, making it harder for them to communicate, to navigate, and to find food.
What's really concerning is the timing. The icequakes are loudest during the Antarctic summer, when the ice is melting fastest. But the biggest conflict, the time when the noise most directly overlaps with blue whale calls, happens in the fall. It's a direct, seasonal collision between a changing climate and the animals that depend on a stable one.
So, in the end, the Bloop wasn't a creature from a horror story. But maybe the reality is even more sobering. The myth of a monster has been replaced by the very real sound of a world in transformation. Which leaves us with one final thought. The monster was never real, but the warning it carries, that's about as real as it gets.